Sairam, we will now begin the second session, and at this juncture, I would like to thank Professor Carlos for a very enlightening lecture in the morning, and also the Vice Chancellor for gracing the occasion with his introductory talk. Now, moving on to the second session, it's my honor to introduce to you all Dr. Anuj Mubai. He finished his BSc in 1997, then went on to do his MSc in pure mathematics from IIT Kanpur and completed that in 2000. After that, Dr. Anuj received his doctorate from the Arizona State University in 2008. He is currently an assistant professor of applied mathematics in the School of Human Evolution and Social Change. He is also part of the Simon A. Levin Mathematical Computational Modeling Science Center at ASU. He is also co-director of Mathematical Theoretical Biology Institute and director of the BS in Applied Mathematics in Life and Social Service Sciences undergraduate program. Apart from all this, he also holds adjunct affiliations at multiple institutions including University of Texas, Northeastern Illinois University, etc. He also held a Gates Foundation Fellowship at the Cleveland Clinic and National Institute of Health's Fellowship at the Case Western Reserve University School of Medicine. His current research includes development of novel mathematical modeling tools to understand transmission dynamics and control of neglected tropical diseases. Today, Dr. Anuj will be speaking on the topic, which came first, the chicken or the egg? He will be reviewing the studies on mathematical modeling of infectious diseases. With these few words, I invite Dr. Anuj to address the gathering. Thank you.
Hello. Yes. Thank you for this nice introduction. So you all have seen the talk of Carlos Castillo Chavez. He was talking about various type of models that that we are trying to work on lately. But this title that I have chosen here, which came first, the chicken or egg, this has always been a challenging task for all of us, especially individuals who are working in interdisciplinary area. Whether, for example, my background is mathematics, so whether I should focus more on mathematics or whether I should focus more on the application that we are trying to focus on. And that is the reason I came out with this title to share some of the research that our research group has been doing, which actually which will reflect some of those aspects. Both are equally important, but some places one is critical than others. So before I go into it, I just want to give the structure of the school or the workplace that I work at. And which one is the pointer? I think this one, right? So ASU is the university, and I am in the department which is called as School of Human Evolution and Social Change. And as the name suggests, it is, you cannot say it is physics, it is chemistry, it is maths, or it is something else. It is a combination of many disciplines. So there are researchers who comes every now and then, actually every week, sit together for a meeting and discuss on various issues, including anthropology problems, for examples, and many other problems of a person interest. And we are actually solving a real life critical problems of today's life. And so that is a department. And then comes a center which is which is initiated by Professor Carlos Castillo Chavez, and now it's called as Simon A. Levin Mathematical Computational Modeling Science Center. As the name suggests, modeling, there are three major aspects: mathematics, mathematical, computational, modeling. Those three things are combined with the science. And that is what skill set are brought in this center. from various, so there are a lot of affiliated faculties who are experts in epidemiology, in social science, and other disciplines who are part of the center. Under that center, we have multiple programs. There is a high school training program, which is called as Joaquim Buster's Math Science Honor Programs. So we train them in the same way as we train our graduate students. So we have high school program, we have undergraduate programs, and we have a graduate program. And actually, some that we are trying again, we applied for some last year, we didn't got funded, but we are applying again for a professional also, early career researchers, to train them into some of the aspects that we do, which is quite different than a traditional way of doing things for example, I graduated from IIT Kanpur, and Professor Satish Kumar, I think he's here somewhere in the audience, he was my mentor at that period of time. So this is a rough structure, and in all of these things, the diversity is very important. Not only national diversity, we have females, we have minorities, we have underrepresented communities in our program, but also international community is very much represented in it. Okay, so he's Dr. Simon Levin. He's a very well-known, distinguished ecologist, actually. But he works also in many mathematical problems, and if you Google search it, you will get thousands of news articles under in his name. And he was our provost before, and Carlos is in the middle of this thing. So he inaugurated our center, and that's why his name appears in our center. This thing. So what do we do in our training structures? So we are bridging the gap. The gap is a very important thing, bridging a gap between what is community needs. Well, we do all these mathematical methods and we learn these methods. What can we do with these methods? How can we use it to solve day-to-day real life problems? We have to think of, and that's one of the things that we focus on. What are the needs of the community, and how we can train our grad students or our peers in those type of methods that are useful to address the current challenges. That is the main goal that we are focusing on. So if you talk about any cutting edge problems in real life, it is cross-discipline. One discipline cannot solve it. And so therefore, we need people from different departments, different skill set, to come together and sit on the same table and discuss about those problems. Okay, so this is general. Let's go to, so we have two programs here. It's called as Applied Mathematics in Life and Social Sciences. Now, remember, I'm giving these things, although it was a mathematical modeling of infectious disease workshop, but I'm providing you these general framework here because environment is very critical for even describing the models, how you tackle the situations. And these all things will help you see in what environment we work and how do we deal with small things into day-to-day life. So we have two programs there. It's a Bachelor in Science and it's a PhD programs, and they both have a very distinct skill sets, and they are trained to the current needs of the US, for example. So for example, we in our classes, we teach how to read, evaluate, and present scientific reports. I don't think I was taught when I was in my PhD program all these things. I learned it by experience. That's a different issue. But this is all the things we teach it in the class, and that makes it a distinct flavor in those things. We also give some kind of outline of where to search jobs. What are the places here, for example? What are the websites in India that you search for a job? What are the places? I'm asking an open question here. What website do we go for searching a job, academic job, let's say? Anyone? We don't have any, right? So how do we get to know all these jobs, search jobs? Well, so these type of information, what is fake news, what is non-fake news, has to be discussed, right? And there's no one an expert in these areas, but when we discuss, there are different views come forward. and there are different decisions that we decide on, and then there is a common consensus of this area would be, this website would be better than that website. So this is all we talked about. Actually, we discuss in an environment. It's not that I'm giving a lecture, but I will discuss with my my students, for example. So also, one of the important things that we do also is we make them, students, PhD students, are part of empirical data collections. So one of my students actually did, for example, surveys to collect the data for their models. So we are not now depending on others to collect the data. And many times we build a model, we do analysis, and then we look for a data, which is kind of going opposite of what mathematical modeling is about, right? Mathematical modeling is about asking a real life questions and then coming backward to think of what is the best model that you can think of, and work upon those by your mathematical skill set, right? So those are the things. So data collection becomes a very critical role in our group. Also, one thing which I never had a chance before was a mentorship. We never get a chance to have a mentorship in our graduate program. I didn't got it. So I think that is very, very important, very, very critical. How do you train someone who is less skilled than you in an area that you are expert in, for example? So those are very critical aspects, and this is, and I will give you an example how do we do it in few slides ahead. Also, this is typical. This is all we learned. We all do these things, current methods in mathematics and computational science, and we know about those methods. But these are equally important, and this all things make us a comprehensive person in that regard. So how to read and search for jobs, how to write effective reports, how to present. An example of survey we actually try to train in my course. I actually train how to write surveys. You know, if you ask you to write around a question for collecting a data, you know, each one of you will be writing a different question for it. And if you give that question to people, they will respond in a very different way. So there is a very specific way to write this specific question. For example, if you are asking, what is your future plans of in your area? And you want to collect a data for that. So you have to write this question in a very, very particular way in order for you to get a right kind of data. So Professor Grillo is sitting at the back, and we are working on a problem. We are doing currently a survey at Arizona State University. We are collecting data for studying the burnout rate. Many students are right now overwhelmed with the workload, and they don't know how to manage these things. So we are carrying out this study at Arizona State with his help, and we are working with psychologists also, and to find it out to what extent this is a problem first, and if there is a problem, what social behavior factors affect those things. Now this is a relevant questions to my campus, for example. Okay. So, and this is also an important point. Once you have the data, how do you extract a good information from it? Because data has multiple information. Not all information is as useful as others. Now, there is something that is very important, and I don't know how many of you heard about Mr. Sonam Wangchuk. I think Mohammed is sitting there, and he knows about him. He's from IT Mandi, and Sonam Wangchuk was visiting your campus, right? Mr. Sonam Wangchuk, he's an educational reformist in India, and he's a national award winner. He is in Tibet, right? He's in Tibet. And Ladakh. And he is, I got to know about him through Kaun Banega Crorepati. And he was interviewed by Amitabh Bachchan, actually. And the interesting point was he made some interesting point, and that just catches my attention. One of the things he does there is he is passionately involved with solving local problems. That is one thing. And when someone is passionately involved, they figure it out, the resources for it. For example, what he did was there were a lot of, these are untrained people, right? And so they were performing very bad in schools. right? Because they were not doing this because the standard was same as we have these boards, like, high school board, 10th or 12th boards, and they were not doing very good, and they were getting failed in the classes, right? So these classes, when they were getting failed, what do you do with that? Do you throw? Well, in Ladakh, almost 90% will have no training before. So you will just throw all 90% of the people? No. So what he did was he started something, he called it as a University of Failures. And the idea was, okay, they might not be performing very good in mathematics, but they might have some other interest other than mathematics, for example. And just let's develop those interests in that person. Okay, so that's what he did as one of the things, and that's how. And there are many things he does in that. And another problem, he uses some scientific expertise and collaborate with ISC Bangalore, for example, and other institutions to resolve some local problems. There is a water shortage, for example, in the winter season there. And so I think you guys should look for this thing, and Mohammed can share the link actually if anyone wants to talk about it. Now, why did I mention this thing? Because I realized that we do something similar, if not exactly. So we have, in our programs, we don't give, my interest is in neglected tropical disease. I don't give the problem, okay, you work in this neglected tropical problem. We ask a problems, what interest is the student interest? For example, Mugdha is sitting here. She wanted to work in gender disparities and gender-related aspects. And so she's working in a problem like this. Caesar is sitting there, and he was interested in resolving waterborne infection in Ecuador. And so he's working in that problem, for example. So what their own interests are coming into their research topics, and that makes it a more flavorful. We only help them to guide in a proper questions and proper way of doing the dissertation and progress smoothly in their dissertation program. So most of the projects are student driven. This is very, very important, student driven. Second thing is, it's a multi-layered mentoring program. So many times we are kind of hesitant to go and approach our faculty. When I was in my undergraduate program, I had a very difficult time. But I could easily approach to my graduate students, for example. So we have multi-layered mentoring system. We have graduate mentors, graduate students who are mentoring undergraduates. And we have early career researchers, postdocs, for example, mentoring graduate students, and so on and so forth. So there are multi-layered mentoring systems, and they can approach to any level of these mentors. Okay, so this is general. And one thing also is they learn from their peers. They learn more from their peers than from me, for example. So every lab meetings, they train each other in the skill set that they know about or they are already trained in. And that is a quick way of learning many of those things which you will never know if you will do it by yourself. I mean, you will not be able to expose that wide variety, basically. Okay. So, for example, I teach a course which is called as Modeling and Simulation in Global Health and Neglected Diseases. Just to give you a flavor, there are speakers. I have it on Skype. They live stream their lectures from remote areas. For example, Swiss Tropical Medicine has a CDC, Center for Disease Control at Peru, for example. Professor Grillo also was doing a lecture in it. So I have my collaborators in different institutes who are talking in these courses, live streaming. I am not an expert in neglected. I have learned it over experience. But these are expert in it, and they can give a first-hand information on these type of topic. And that's why I invite them to come and give a talk through live streaming through that. And our students actually do a surveys, and this is a flyer for carrying out a survey at an ASU campus, for example. Okay, so most important thing that we focus in a viable research question. What is the need, community need right now? That is a very, very critical aspect. Mathematics is a tool. that we work on. And you of course, your tool, you need to know about it, but then you have to address a viable research question. That is what our focus has been in our programs. Okay, so just to give you an outline of it, students are across from disciplines, different disciplines. They of course receive in quantitative mathematics training, but they not only receive mathematics, they receive statistics training, they receive computational training, but they also are allowed to work with someone in other department, for example, biology department or in social science department, or the choice of their interest, basically. We help them to collaborate with other faculties. And many times, those other individuals are part of their dissertation committee, for example. So as I was talking about, there's a flipped hierarchy. The project ideas come from the students, and we just guide them. So we are not aware of those ideas many times, but those applications, and we basically help them asking a logical questions, and that's how they design their viable research question. Okay, so I don't want to bore you all, but some of you might not, because I was not aware. I thought of what I should give a lecture here, but I thought many things I was not aware of when I was in my undergraduate or graduate program. So why not just expose those things that you would maybe knowing about it, but maybe not. So so PhD dissertation is usually guides your positions. What topic you work on, what application you work on, actually helps you decide what position you should go for. It's not everything, but it's a good start, and you have good tools in your basket that you can work on various things. Okay, so now in US there are 4 different types of academic institution. I'm guessing here also there is 4 different types that we. So primary research academic institution, ASU, Arizona State University, is primary research and teaching academic institution, where 50-50 is given weightage for teaching and research. And teaching academic, mostly teaching that is preferred. And there is partially academic institution. For example, I work for a Cleveland Clinic in Ohio, which is one of the top-notch hospital in US. And there are departments, but they also have patients. Okay, so they are teaching courses, but they are also handling the real-life problems. So they are partially academic institutions, for example. And the requirement for the hiring in these things are very different, for example. So just to give you what are the requirements for it, so when research and teaching academic institution you have to go through phone and on-campus interview. Phone interview is separately. If you get shortlisted in that, then you go for an on-campus interview for 2-3 days. And then the course load that you teach on a daily basis is 2 courses per semester. So 2 + 2 means 2 in the fall and 2 in the spring. And then there is a research expectations, because it is research and teaching academic institution. You have to know where you are applying, for example, there. And roughly around 15 to 20,000 is the capacity in US of the students that constitute that type of institutions there. Then comes the primary research academic institution, which is phone and on-campus interview, same thing for getting hired. But then the reduction in teaching load is very reduced, sometimes even 0 and 1. But you are expected to write a lot of research grants, and you have to expected to bring a lot of grants for it. Okay. So this is the department building. I should have had a different picture, but my department building. So the application material, this is very important. You know, we had this forms. This idea came to me because we have this Google Forms where you were entering these data for this workshop, this particular workshop. And I saw CVs of some of you, actually all of you, who applied there. And something I notice in some of the cases that the CVs are very different in the way we focus on. And I think it is very important how you structure your CV because it captures what is the essence of your background in a much good. Remember, the people that are evaluating at any stage do not have much time. They are very busy people. So they would like to see these things very quickly and very fast and to get your idea of the individuals in just few minutes actually. And until unless there is some reason why they want to go details into it. But these are the main things that the cover letter is very, very important. Cover letter is a gist of everything, teaching, research, service. And these two things are also very important in research statement and teaching. So we spend a lot of time in writing these things because this gives a flavor of what type of background an individual have. We can quickly make it out from the first paragraph whether a person has really spent much time in writing those things or not. Is that the same procedure here for getting hired an academic position here? Is the same material? Okay, so our center and school and programs at ASU are interdisciplinary modeling areas. So as I was saying, my department consists of all these areas actually. And we have multiple programs which kind of feeds up, which gives you a mentoring, students to a mentoring abilities, because the undergraduates are training graduate students are training the undergraduate and so on and so forth. I hope it is not boring, by the way. So please stop me, I will rush to the next slides. And okay, so these are some of our recent graduates. For example, he graduated, his name is Carlos Toro. He graduated in 2009. He's a VP of JP Morgan Chase Bank, for example. Daniel Rios, he graduated in 2010. He was earlier in Goldman Sachs. Now he's working for government agency that he can't tell us. It's a secret US government agencies. And David Murillo, he's working for American Express. He graduated in 2012. Kevin Flores graduated in 2009. He's a professor in personalized medicine at North Carolina State University. This is actually for him, they made the department. I mean, they were thinking of that department, but they hired him. That was the first few set of individual hired for that department. He was one of them. She's working for Romary Morales. She graduated in 2016. She's a research scientist at Pacific Northwest National Laboratory. And Beverly Gonzalez graduated in 2015. She's a mathematical statistician at United States Department of Veteran Affairs. So the reason I'm showing these examples, and there are many more, is that we are developing their skill set and they are going in a very different disciplines of their own choice. If they want to go in academia, that's well and good, but if they don't want to go to in other areas, that's also good. And many of the institutions like US Department of Veteran Affairs, they are doing research also. National laboratories are also doing research, just like the universities, for example. So we also organized, this is one of the example of the workshop, but we also organize workshops at various places. So I was there in Portugal last year, invited by Professor Grillo, which was very, very unique in that there were people from many different disciplines to talk about. But also in 2019, we are organizing a workshop in Banff. Banff is one of the beautiful places that I have traveled. And it's really gorgeous. It's a heaven actually on earth, I feel like. There's a glacier there, there's a handful of people, it's in Canada. It's in Calgary, province of Calgary in Canada. And we are organizing it in 2019 and it looks like this. Look at how beautiful it is. And there is a mathematical research station there, and they fund to organize a workshop in Canada and US. There are a lot of these organizations which funds those funds. So we are organizing there, and there are scientists who are coming there for that workshop, social scientists, biostatisticians, psychologists, medical doctors. It's very interdisciplinary. although we will be talking about mathematical and computational modeling aspects of it. Okay. So Professor Carlos Castillo Chavez started this Latin American consortium. Latin America is South America, Central America, and some parts of Caribbean that constitute the places where Latin is spoken. And so there are lots of members of this consortium, and it was initiated by him. And this was in El Salvador. This is in Colombia, and it's Mexico and Ecuador. And every year it is different. We have a meeting with. But this is the workshop in that direction, and I wanted this India to have some type of consortium also. And that's how I'm just exposing you what we are doing right now, and we are not only restricted to US, for examples. This is the workshop that we organize every year. The 5th one just culminated. It was in Colombia. And it's an international workshop. Every year the focus changes. Now, the focus of it changes, but we have individuals from mathematics, statistics, computation, but also from economics, also from medicines and other areas, depending on what is the focus of it. Now, we also make our presence felt through social media. It is very important in nowadays. Well, it is a balance that we have to maintain in terms of how much time we want to spend for our social aspect versus professional aspect. And that is always a delicate issue. So we have a Facebook web page. For example, there are a couple of Facebook. This is one is on the top and the other one is on the bottom. And anyone is free to join those two groups, by the way. There's no restriction in that. So please do that if you are interested in something like that. And also we are on the Twitter, for example, and we regularly feed the Twitter feeds. And as we are saying, this workshop will be also in the press release very soon. So one of the programs that I co-direct is called MTBI, Mathematical Theoretical Biology Institute. It's a undergraduate research programs, and this is the group from 2018. Let's see, where's Professor Carlos Castillo Chavez is here, I am here, and I think Dr. Debroy was here, in the MTBI a few years ago, and Mugdha and Caesar was also there a few years ago. And so we had some, Professor Sheshiar was also part of that, and he is a regular visitor of our center. He's a faculty in our center as well. So he is part of many things there. So let me say, this is an undergraduate research program. But you will be surprised to see how they work. Let's see. There are around 130 PhDs. So we had 500 graduates from this. This is a 2-month summer program. 500 up till now have graduated through the summer programs. 130 of them, these students were not really interested in mathematics when they joined this program. We took only those people who will not go get these opportunities. We typically selected from the smallest school with few resources to come and visit us, and we pay them for doing that. We had flights, we have hotels, we have food, we have a stipend for them, and it's a good amount of stipend for them for 2 months. And they come there and they kind of learn these mathematical modeling tools and the way we teach these methods to them. So there are, every year there are 200 people, 200 students or more, like 200 to 300 apply for just 20 spots, So it's a very cutting edge in that regard. Of course, not from India standards, because we get lots of application in India. But from US standard, it is a huge actually. In this, one of the important things are homework and the group works are evaluated, not graded. There's a difference in evaluation and grading. We go over their steps, but we don't give 100%, 90%, 70%. We don't give that, or you fail or you pass. We ask them to redo the homework if they have skipped some of the steps. That motivates them, or that motivates them to ask their peers to learn and do these things again. And that's how they learn it very fast. And again, the topic of the project that they work on comes from these undergraduate students, first time seeing these mathematical modeling skills, first time seeing the application, but they all have their own ideas. You know, one of the group started by thinking they want to solve the world poverty, which is kind of a very big problem, right? But we help them to guide into smaller and smaller problems. And there is a 1 week long session where around 15 to 20 faculty mentors that sit in the room, and these research group starts to talk about their research ideas. And we help them on a viable research question of the problem of their own interest. That is important there. And so we form the research community. The website, the Twitter or email, the community is built by that. We don't just leave them in the summer. We're done summer and they're done. We involve them throughout. Once they are part of MTBI, they remain part of MTBI throughout. They start their session. This is 2 months long. They start their session at 9 a.m. in the morning with the lecture 1, lecture 2. By the lunchtime, they have a student problem. This is done by the graduate student problem session. Then they have a lunch for 1.5 hours. Then they have a computer labs where they are learning many different softwares, not one. They are learning Python. They are learning QGIS. Have you heard of that? QGIS? It's a geographical information system, for example. They are learning NetLogo, which is an agent-based modeling technique, softwares. So there are many softwares they are learning which are easy to model, use in the models and apply. And then they all sit, faculty, graduate students, undergraduates, they all sit in one room and eat together dinner, which is, we call it as a mentor meal. And then 8 to 11, they have a homework from the morning lecture, and they end around midnight. We don't force them, they work, and they have to teach each other if they have a problem. They work in a group. So they are doing these things 6 days a week, 2 months. It's for undergraduate students who are not exposed in this environment ever. So it is very challenging to them, but they do it fabulously well, and they work because it's a community we are building. We are not teaching them as a lecture, for example, and that makes a difference there. And it's a very successful program, by the way. It has got 2 presidential White House awards so far. So let me go. How many minutes do I have actually? Like 10, 15 minutes? We'll start it at 11, right? 11:15. Okay, so I think I will not. I'll go to my work now. So modeling trends in infectious disease. Actually, infectious disease has a very long literature, although we never get a chance to go over back that much of literature. And it is very important to know the difficulty that other researchers have faced in the past. So it starts from John Grant in 1620, when they talked about, the smallpox was the big problem during that point of time. And they tabulated the mortality of smallpox. So the model there was just the table. Well, we talk about models just by differential equation. Every field, the model world is used in a different way. But their idea is to make the complex system. Oops. I moved my hand a lot. Thank you. Thank you. So the idea here in the modeling is to take the complex systems and how do you make it concise that a human mind can understand. That's the idea of the model. It could be a written words, it could be equations, it could be a flowchart diagram, or it could be something else. Okay, so it started actually in John Grant by 1620, and there has been some pioneer work by Daniel Bernoulli. There are many theorems on that, for example, and many of them. William Farr also talked about some stochastic model, for example, and so on and so forth. Carlos was mentioning about Ronald Ross and Cormac McKendrick, which actually transformed, and the way the people were modeling, in the sense that they introduced the topic of tipping point, when the system tips from one in mathematical terms when the bifurcation occurs. And that is what the role of this 3 pioneers have been. Now, we actually work on complex systems in some sense, because the problems where even infectious disease itself is very complex in that regard. So we use, you see the evolution of different methods over a period of time. There was optimization and probability game theory. There was certain types of models that were used in 1970s, but now they are taking roles in network science, and they are using models from different disciplines to combine the new methods. Right now, it's not that one size fits all. It's not that the one method, this is the most advanced method and you can use it everywhere. It's not that. But this is just showing what were the community needs and over a period of time how the methods are developed. Okay, so these are some of the evolution of the methods there. Dr. Debroy and I just published, I mean not just, but it was published in I think 2017, 16? Last year, 17. It's emerging themes in epidemiology. Now, it is very difficult to, we are mathematicians, right? So writing down the story for a non-mathematical audience and publishing it in the epidemiological journals is very challenging. Mathematical journals, we can publish at any time. I would tell you that. But these ones, initially we got rejected many times, but now it is fine. I mean, we learned their tricks. But in this paper, what we did was we did a comprehensive review. One of my area is Kala Azar. How many of you know about Kala Azar? Anyone? Kala Azar? So where are you from? Which place? Here? In Bangalore? But Kala Azar is not here though. No? It's in Bihar, right? So where are you from? You're UP. But UP also has it. So Kala Azar is scientific name is visceral leishmaniasis. And it's a major problem in East Uttar Pradesh, Bihar, and West Bengal, and actually Bangladesh, Nepal. And it's Bihar is one of the highest prevalence in the world. And it's a neglected disease because it's a disease of poverty. And so not much attention is given to it. And so I work on this. I work with Indian Council of Medical Research here in India. And I collaborate with Rajendra Memorial Institute of Medical Sciences in Patna. You might know about it. And also, BHU has a clinic in Muzaffarpur in Bihar, BHU School of Medicine. So I work with both of them, and BHU is Banaras Hindu University, right? So to collect the data and to go and see if what data we need for that. So what we do we reviewed many of our studied and and collected the methods and the data set that we are using in those, what data sets are needed in those type of methods. So for example, there were climate models where we were using meteorological data. Now there is no differential equation type model. This is a time series model. It depends on what question you are addressing that you have to choose the methods here. Right? So this is what is explained. I would strongly advise you to actually go and see if you can get a hold of this paper. If not, send me an email and I'll send you a copy of it. But this is a very good written paper which reviewed in a more in Indian scenarios, what are the challenges from the modeling perspective. So let me give you some example from my study. So one of the study that I work was on HIV transmission, and every study that I will present here, I have few examples of it from my own research. I will talk about research questions, the viable research question, which are critical here. So in this was the work we were doing in 2011-10 around that time, and it was on pre-exposure prophylaxis. This is a kind of vaccination. Oh, it's not vaccination. It is a pill that you, if you take it, you will not get HIV. The problem with HIV is that person who get infected often get delayed in reporting, and therefore these viruses goes inside the body, well hidden inside the body, and you can never wipe it out. But if you go in a certain window period, which is few days treatment, then you are cured of HIV. For example, healthcare workers, by accidentally, when they get infected, they take these pills and they get immediately cured of that thing. So that is what is a problem, that window period is missed. So pre-exposure prophylaxis was a pill that were being tested in South Africa by a research group in University of Philadelphia by physicians. Some of the physicians there in South Africa was the largest prevalence, by the way, that time. So we wanted to see, so ART, where is ART? ART is antiretroviral treatment. Antiretroviral treatment is the treatment for HIV. PrEP is also a medicine that is the same medicine given in the PrEP, but you take it as a regular pill if you think that you will get that HIV, for example. So the question that we are addressing here is, if you give more medicine in the population, so you are wasting. So PrEP, for example, you are giving a medicine and some people may not be infected and they will be taking it, right? You are giving more medicine in the population, it will cause more resistance cases. Think of that. You have developed the drug for 60, 70 years. You don't want to waste that research by creating more drug resistance cases, right? So the question now comes, if you want to implement the PrEP, whether you are getting benefit out of it more versus drug resistance or not. So that you have to evaluate using mathematical models. Okay, so this is what the such study was about, and we built up the model, and this model was coupled nonlinear differential equations, HIV model differential equations, as many of you might have seen it, but think of the complexity it is involved in. Now, it was not the choice of us. We mathematicians don't like complex models. We like simple models so that we do mathematics on it. But this was, since I was working with the medical doctors, they wanted to do a lot of detailed study on that. And therefore, they have male and female in that. There are sexual activity level in that. There is whether PrEP is there, ART is there. And there is infection stage. There are different infection stages at which you can give these type of treatment. And there was drug sensitivity. There were 2,300 differential equation coupled into it. Think of that. Can you do any maths? No, you cannot do. But it is addressing the real life current challenge. Now, that was the need of this problem. That doesn't mean that I would suggest you guys to do all these problems in that manner. But in that way, it was needed. Now, we were running the clinical trial, so we had all the data in hand. And that was the best part of it. And so we could make it more complex model in that sense. Okay, so what was the result? The result was ART and PrEP is combined together has a more beneficial role than each one of them separately. Okay. Second was, they were thinking this PrEP will introduce more drug resistance. In fact, the treatment, regular treatment, was misused so much that was, turns out, mathematical model was telling us that the treatment itself is causing the drug resistance more than the PrEP that we were trying to implement. So this is not a natural answers to some of these problems. You can't get these things without some kind of mathematical structures or understanding over a period of time. This is study 2. This is published in Acta Tropica. It is very pioneered journals for studying tropical medicine, basically. And here, the idea is these are Trypanosoma cruzi. It's another this is a pathogen which causes Chagas disease. How many of you have heard of Chagas disease? Anyone? Chagas disease? It's common in America, but it's a neglected tropical disease. Neglected means not heard much about it. And here the problem was we were modeling raccoons and wood rats, and these are vectors. These are vector-borne disease. That means these vectors bite, and that's how this infection is spread. So the problem here is we were modeling in the wildlife these things because people, when they go to these wildlife, that was the source of the reservoirs, and they were getting infected while going to this thing. So we wanted to see, but there was no data available for the wildlife, right? What was the data available? The data was available was ecological. It was the life cycle data that was available, but the contacts, the transmission data was not available. So how do we generate these data, or how do we find this data? So then what we did was we used a simple agent-based models, not simple, actually it was very complex. And we generated, used these alternative source of data into this agent-based model to identify what is the transmission coefficients in the wildlife. We had a habitat structure there, we had a density structure there, those other sets of data. So this is, the role of mathematical model is not only about generating hypotheses, but also for collecting data. That is what I'm trying to say here, using another source of data. Now, this is not empirical data that you are collecting from the field, but this is model under certain assumption, this is the data that you are collecting. So again, the tool was agent-based model, not differential equation here. This third one was in India, and it was published in one of the top-notch American Journal of Tropical Medicine and Hygiene. It was done by one of my PhD student, Kaushik Gaurav, in 2013, I think. So this was with Rajendra Memorial Institute of Medical Sciences in Patna. And there they talked about that we are spending, this was the question came from them. They were saying there's lots of money that we are spending in Bihar, and the way we distribute resources there in Bihar are based on counting number of people in each district, and that's how we allocate insecticide. Now, this is a vector-borne disease, so you need to spray insecticides. So they count number of people, and that many kgs of insecticide is distributed in each district. Now, note one more important thing here is that this is a vector-borne disease, and in Bihar, if you have gone, in fact, in anywhere in India, there are a lot of kettles. Have you guys seen that? A lot of kettles and kettle sheds in the same town as the people are living. Now, these biting are proportionately distributed in these kettles. If we don't take into account those things, or we don't take into account the places where these kettle sheds are, or how many are there, we are kind of overlooking a major point because many of these disease is spread by sandflies. And sandflies are in these kettle sheds. They are found in kettle shed. We are wasting our resources if we don't focus on those aspects. So what we gave them an idea about, we built a model using spatial structure where we had kettles, we have humans, we have kettle sheds, we have housing, and we wanted to see how we should distribute the resources with the same budget in hand. Okay, so the present allocation was 37 grams per person. That's how they were allocating it. And they were only focusing on only human earlier. And we used optimization problem in it. And we figured it out that if you use DDT, the amount is so less per person, but you have to also distribute in the kettles. You have to count the kettle also. So you have to need the other data set also for distribution. No other data. And for deltamethrin, which is another insecticide that is commonly used in that area, those numbers are different. Now, and you have to cover 4 times the number of kettles to optimize the availability. And you will achieve 20% more reduction in cases. So this was the idea that we provided, and they are now implementing it actually in Bihar. So we worked with the Bihar Society through ICMR. What is it called? Bihar Health Society. I think it is called Bihar Health Society. Okay, study 4 is about Zika was one of the study. Let me ask again, how much time do I have? Oh, we are short. Okay, so this is the last work. So let me wrap up with this. This was a Zika outbreak that started in 2015 in Colombia, and it was growing. When the outbreak happens, the data is very underreported. But it grows exponentially because the interventions are not yet implemented. So how do you find out what is what is the intensity of the growth of the infection? And we were one of the few ones when the outbreak was going on to say something on those lines, and we predicted it is and of course we use a mathematical model for it was a rate of exponential rise is this much, rather than many other studies which were predicting for that. This was specifically for Barranquilla, Colombia, because we could get some data from there. So I hope I will stop here. Yeah, I have few more studies, but I will stop here. And I hope it was interesting enough in that regard. And if you have any question, feel free to ask me. Thank you.
Thank Professor Anuj sir for his talk. We thank Professor Anuj for his talk. Sir, our token of love, sir. No, we have back for everyone, sir. So. Thanks. If you have any doubts in the afternoon, we have hands-on session with being handled by Anuj sir and Professor Seshia. So maybe doubts will take that time. Because of lack of time, I think doubt session will keep it in the afternoon.